So we're looking for the stationary points or the turning points. So just in general, if we have some function, stationary points occur where the tangent slope is 0. Remembering that the derivative f prime x is the slope of the curve at any point, the stationary point occurs where the slope equals 0. So we would therefore set f prime x derivative equal to 0 to determine the stationary points. First thing to do is take the derivative then. So we're going to determine f prime x. This is straightforward. 5x to the power of 5 minus 1, so 4, minus 16x to the power of 1 minus 1, or 0, so we won't write anything there. Next, we set this equal to 0, again, because the derivative represents the slope, and the slope is 0 at the stationary points. So by setting this equal to 0, we can now isolate for x. If we had some polynomial function with more terms that had x on it, then we would have to actually factor with long division or synthetic division. But this is actually pretty straightforward when there's just one x term. So isolating for x will move the x term to the left side, and that would become negative, and we'd have negative 16, but then multiplying both sides by negative 1, they would both become positive. Isolating for x, we get 16 over 5. Finally, we take the fourth root of both sides. The fourth root will remove the power of 4 on the x for us. And when we do that, don't forget, we always have two possibilities. It's either a plus or a minus. So whenever we take the square root, fourth root, it's got to become plus or minus. Why is that? Well, if we have something like x squared equals 4, this x could be positive or negative. If it's odd, then we would actually know it has to be positive always, though. Positive. It's always plus or minus if the exponent is even. Because if this was negative, remember, an odd exponent would keep it negative. We'll simplify this a bit. Remember, with fractions, it's like having the fourth root of 16 over the fourth root of 5. We can do that. It's one of the rules for roots. 16 is 2 to the power of 4. So if we have the fourth root of 2 to the power of 4, 4's and 4 will cancel. So we have 2 over the fourth root of 5. And we could simplify this further. But I'm going to move on to speed things up. So this is plus or minus 2 over the fourth root of 5.